Is the homework gonna be tangible again?
All right, so what I want you to do before we get into our theorems for today, I'm going to give you two problems that I would like you to solve. Okay, two Pythagorean theorem problems. Go ahead and solve for x. Simple triangle form, please.
Oh, isn't there something like this?
Yep, but we're not using that yet. We're going to use this to help explain that. But you're absolutely right. That's why we're doing it. We want simplest radical form for our answer. Can I talk to somebody about them? See what they got here?
I got what you say. And then the second one I got 5.
You can start a calculator.
All right, here we go. Here we go. So you here, raise your hand, what is our simplest radical form for x here, Brody? 4√2. Break that into 16 and 2. We got 4√2. So we have 4√2 here. What is this one going to be? Say it again. 5√2. Thank you. I was distracted by the people talking in the back.
Yeah, come on. Get ready.
Braylon, Aiden, knock it off. Okay, so we got 4√2, we got 5√2. This is what that first theorem is talking about. Okay, that you have copied down. Is in a 45, 45, 90 triangle. And by that we mean, and I'll put it up there in a second. What we mean by that is these are 45 degrees. So you got a 45, 45, 90 degree triangle. We know in a 45, 45, 90 triangle, the legs are always going to be the same because it's isosceles. So the legs are going to be the same. And then the hypotenuse is just whatever the legs are times the square root of 2. So it's a shortcut. We don't have to use Pythagorean theorem anymore on this specific triangle. We can simply use that pattern to get our third side. All right, so let's take a look at that theorem. Our 45, 45, 90 triangle theorem here. It does have to be a right triangle, we know that, and specifically a 45, 45, 90. And this tells us in that situation, the hypotenuse is √2 times as long as each leg. So whatever the leg is times √2, and we get it.
Do you have to use these theorems, or can you just use Pythagorean?
You could, it's really going to cut down on your time if you use this though. Okay, if you're going through the homework tonight and you're trying to use Pythagorean theorem the whole time, it's not going to be as easy. The next one, the 30, 60, 90 that we're going to talk about next, you have to use the shortcut. There's no other way. All right. So it's always going to be x, x, x √2. So this is the general form. So anytime we talk in general about a 45, 45, 90, we're talking x, x, x √2 as our three sides. Okay. We can tell that it's going to work if they give us a 45. Okay, they don't need to put both of them if just one is fine. Because if we know one is 45, the other has to be as well. The other situation, the other way they might show it to us is they might show us that it's isosceles. And base angles theorem tells us if it's isosceles, the base angles have to be congruent, which means they both have to be 45. So either they give you the 45 degrees, they give you that it's isosceles, then we can use this pattern. All right, so we saw a couple of examples of it on what we just did before we looked at this. So if I had this situation, what is x going to be? 10 root 2, right? 10 root 2. I know these are congruent, right? So it's a 45, 45, 90. I know my leg is 10. This has to be 10 root 2.
You can find an answer
Without doing any work. You just look at it, you know, right? That's the whole point of this. It's a very, very much a shortcut. Yeah. I mean,
So what was the name of the check mark again?
square root,
Yeah, how do you say it? Like the root two?
root 2,
Oh, so it's root.
root 2. Yeah.
Okay, check. I've been calling it check mark.
Okay? Yeah, that's root 2. Root 2. So 10 root 2 is the easy way to say it. 10 root 2. So they give you that leg. All we have to do is multiply it by root 2. We just gotta be careful. Sometimes it's not always going to be a whole number. Okay, maybe they do 7 root 2 here, and we want to find out that hypotenuse. We just multiply by another root 2, right? Whatever this leg is, whatever the legs are, we're going to take it and then we multiply it by root 2, right? This is 7 root 2, so this would be 7 root 2 times root 2. What is root 2 times root 2? 8 root 2. Root 2, we're not adding. If it was adding, it would be 8 root 2.
Wait, but I thought you said treat it like a variable.
If we were adding, it would be like that. But you're multiplying. And what I said was when you're multiplying by another root, that's going to be different. Okay? If we're multiplying square roots together, you just multiply the two numbers and keep it under the square root. So technically, root 2 times root 2 is the square root of 4. But we know the square root of 4 is 2. Okay? So anytime you're multiplying two square roots that are the exact same together, they're just going to equal what's on the inside. So it's 7 times 2. So that side length, that hypotenuse would be 14. Okay, so we just got to multiply whatever the leg is by root 2. All right, any questions on that situation? Take that leg, multiply it by root 2 to get there. Now, the other way they're going to show it to you is they might tell you that this is 8 and they want to know what the leg is. We're going the other way out. But we know from our general form that the side lengths are x, x, and x root 2. Right? If you're ever stuck right in that general form, right in that x, x, x root 2. Because we're not just multiplying by root 2 here. Right? It's a little more involved here. But I know that 8 is the x root 2. 8 is x root 2. If I want to solve for x, well, now this is exactly number 1 from the warm-up. Right? And that's why we did it. Go ahead, solve for x. I want to figure out what x is here. Hopefully you either remember how to do this or you wrote it down for the warm-up. Because it is the exact same question. Talk to somebody about it. What was that going to be here? Right, so if we go through the whole process, right, we go through that process that we talked about in the warm-up, we're dividing by root 2, rationalizing the denominator, simplifying, what do we end up with for x? What's this gonna be? Brody? Say again?
4,
Not just 4,
root 2.
4 root 2.
But what is x be 4?
No, x is gonna be 4 root 2. Because if I take this 4 root 2 and I times it by root 2, I'm gonna get 8. Right? This is my x value right here. It's at 4 root 2. Okay? So the book is gonna take you through this whole process every single time. But being the bright young minds that we are, if I'm gonna go from here to here, all I need to do is I need to multiply by this. Okay, basically what that's doing is that's rationalizing the denominator for us. So instead of doing this divide by root 2 and then have to go through that whole process, we're going to take whatever that hypotenuse is, we're going to times it by root 2 over 2, and we're going to simplify if we can. 8 root 2 over 2, we simplify that like a fraction, 4 root 2. Okay, if it's not divisible by 2, let's say it's a 7. I'm going to go from the root 2 side to the x side. I'm going to multiply by root 2 over 2. If that's not divisible by 2, then that's my answer. 7 root 2 over 2. And we just leave it just like that. Okay, so that's the easy way to do it, the shortcut here. And that's anytime you're going from that hypotenuse to the left. Just multiply by root 2 over 2. Okay, Brad?
So you end up like use that.
You could technically say that's 3.5 root 2, but I'd rather deal with it as fractions. That's what you're going to see on big ideas. Okay. Any other questions on our 45, 45, 90? Okay. Let's make sure on those before we move on. Okay, talk person next to you, what are we going to have for the x values here?
Okay, so for number 1, for a, it's going to be 8 and then for I, and then
Hey, don't overthink that second one.
oh, it's going to be 5 or 6. Oh, no, it's going to be 5
Wait, why is that? 5 times root 2 is 5.
All right, here we go. For A, we have 8 root 2. There you go. 8 is the leg. So 8 root 2. How about for B? What are we going to for x here? Brennan? Just 5, right? Because that 5 root 2 is the hypotenuse. That's the x root 2 side, which means x is 5. Okay. All right. Good deal. Let's move on. We got another one to look at, which is the 30, 60, 90. This one's not as straightforward. There's a little more to it, just because there's 3 different side lengths. All right, 45, 45, 90 is nice because it's either x or it's x root 2. And those are the only 2 choices. Here, with a 30, 60, 90 triangle, we know all 3 sides are going to be different lengths because all 3 angles are different. So we've got x root 3, we've got 2x. Make sure you have this triangle in your notes at the very least. Okay, you got to have that triangle in your notes so that you know what side is what. The words, I mean, studying the words is not as good as knowing the picture. The picture is what's going to help you. So the side across from the 30, so the shortest leg, that's always going to be considered x. Okay, that's what everything else is based off of, is that shorter leg, the one that's across from the 30 degrees. Because then we take that and we double it for the hypotenuse. And we take that x and we multiply it by root 3 for the other leg. Okay, this right here, you need to learn that. You need to know it. It's not on an orange sheet. It's not going to be provided for you. You need to know these relationships, that it's x, 2x, and x root 3. So they're going to give you different situations, right? They're going to give you one of those sides. You're going to have to solve for the other. You cannot use Pythagorean theorem for this. Okay, there's no way to use Pythagorean theorem. If all they give you is the fact that this is a 4, and they want both of these, there's no way to set up that Pythagorean theorem. You have to know the shortcut. Okay. So if this is 4, what's this going to be? 8. What's this going to be? 4 root 3. Nice and easy, right? They give you that x. Nice and easy. As long as we remember what those sides are, we've got it. Okay. If they give us a 10 here, right? What's this going to be? 5. What's this going to be? 5 root 3. Nice and easy, right? So the trickier part comes in, what if they give us the number here? Okay? I want you to talk to somebody, okay? See if you can figure out what those other ones are going to be.
Oh, okay.
Maybe try to use some logic from that 45, 45, 90 that we just did. See if you can think what we need to do.
What? Sure. Okay.
Okay, I guess we're done discussing. So in that 45, 45, 90, right? I told you to kind of think back to that. When we had the x root 2 side, when they gave us that one and we were going here, we multiplied by root 2 over 2. Now we've got a root 3 side that we want to go here. What are we going to multiply by? Root 3 over 3. And then simplify it if we can. 12 root 3 over 3. 12 over 3 simplifies down. So I got 4 root 3 for that side. If that's 4 root 3, what is this going to be? 8 root 3. Right? And that's where we just multiply that number that's in front. Okay, so it's the same idea that we had with the hypotenuse over here, multiplying it by root 2 over 2, only now we're going root 3 over 3. Because that's a root 3 side for root 2 side. That right there, that is the trickier of the situations. Okay? More people get this wrong than anything else that we do today. So just be careful on it. Yeah. Questions on it? Okay. Let's practice it. I got 4 of them for you here. The 45, 45, 90, the 30, 60, 90, you got both of them in here. Okay, so pay attention to which one you're working on. Go ahead and solve for those variables, please.
Wait, what is 4 asking for?
4 is asking for the height for h.
36. What?
If you haven't yet, talk to somebody about it.
I got it. I did the all three. Actually, he's very. Number one, two, three, yeah. And then number two. And then number three. Or two, three.
Okay, here we go. What do we have for number one? What's number one gonna be? Brody?
It's two.
It is two. Wait, two. Because this is the x root 2 side, right? And so if we take off that root 2, x is 2. X is 2. How about for number 2? What is number 2? Ready? 2. 2 is 2 as well. 2 is 2, 2. Yeah, 2. Because you got root 2, and now we're timesing by another root 2. Root 2 times root 2 is 2. We'll have a 2. Number 3 is 3. Number 3 is 3. Because this is the x side across from 30. This is the x root 3. So I got root 3 times root 3. So predictable. Which is 3. What about number 4? Does not follow the pattern. Yeah, bro.
Actually, I think I know what yours is. Is it 2 or 3?
It is 2 root 3. It is 2 root 3. So hey, this is an equilateral triangle, right? Every side is 4, which means all of our angles are 60. And if I cut this exactly in half, that means this is 30. So I got a 30, 60, 90 triangle there, right? I've got 2, I've got 4, so x, 2x, this is x root 3, so 2 root 3. That height. Good. I got one more question for you, and then we're done. I'll look at a little real world situation here. Real life.
Actually, kind of looks like the real sign.
Because it's a picture, it's a real sign. All right, we're looking for the area of the sign. Okay, work it out with somebody. Find the area of the sign. We're going to round to the nearest whole number, so no decimals.
Yeah.
Yeah.
Well, if it's equal, so what do you think? 36.
No, it's based on like.
So if you had 648.
I think 13.
So it'd be 18. So that would be 36. Why? But are we finding the area? And you have times space, times like 30. This is the 18. And then 18, 36. Then root 3. Root 3. Oh, 18 plus root 3.
That's not the answer.
Yeah, okay, so it's just 36. I feel like it's almost a trick question.
Not a trick question at all.
Well, this
Is
be
everybody
like-
working?
this be 36.
Yeah, why? 18 or 3 times 36. 8.
Give me an actual number. 30. Give me a whole
You
number.
guys, come on, it's
Round
an
to the nearest whole number.
equilateral triangle, and you're estimating the area.
That is what it's saying.
Yeah. So why would you need to find the height of the triangle?
Because that's how you find the area of a triangle.
Triangle.
So you find the area of a triangle by finding the height. All right, 1/2 base times height. All right, hey, here we go. Here we go. Again, it's just like that last one with the 2s and the 4s that we looked at. It's equilateral. Equilateral, which means if I cut it in half and I need that height to be able to find the area, I need the height. I cut it in half, I got 18, I got 36. This has to be 18√3 because it's a 30, 60, 90 triangle. So I got my base, I got my height. My formula is 1/2 base times height. So I'm looking at 1/2 times 36 times 18√3. I type that all right into the calculator and I round it to the nearest whole number. What do we get for that? 561. And it would be inches squared for the area. Right? Any equilateral triangle, you slice it in half, it becomes a 30, 60, 90. And we can easily find that height. Okay, that's something that we weren't able to do before. Okay?
Are those sides really 3 feet wide?
I'm sure some of them. I mean, 3 feet is
That's a yard.
this.
Really?
That does not.
So depending on where the sign is, right? I think most of them are smaller than that.
Probably like.
I'd say maybe 2.5 feet, but what do I know? All right, that's it. Go ahead.
I used to